Friends, welcome again today. Today we're going to proceed with a transformer. On our previous discussion, we were able to discuss the above block diagram on power supply topic. So today we are going to go into details of each block. So today we are going to start with the transformer. So I'm sure some of us have come across this. So this is how a transformer looks like. I'm sure you have seen these ones around. Now let's go. Today I'm going to do into details. A transformer has a primary coil to which input is given and a secondary coil from which the output is collected. Both of these coils are wound on a core material, usually an insulator. Insulator forms the core of the transformer. The following figures shows a practical transformer. So this is the figure. So this is how a typical transformer looks like. It has two windings, the primary windings. So these are the windings here and the secondary windings. So this is where we connect the input voltage and this is where we collect the output voltage. Now let's go slowly with our discussion. So from the above sentence, so this is the magnetic core that we have discussed. So this is the magnetic core on which the windings have been. So there are some things we need to get familiar with the transformer. So a transformer is usually a very complex topic. We are only discussing because we have to use it in our project. So we are discussing it slowly. From the above figure, it is evident that a few notations are common. They are as follow: NP, number of turns. Okay. So in the primary, we have the number of turns of coil that forms a primary side of a transformer. So this is the primary side, this side. So the number of turns in the primary, so these turns here in the primary side. We have NS here is the number of turns in the secondary side. We have IP, which is the current on the primary side. We have IS, which is the current on the secondary side of the transformer. We have VP, voltage across the primary of the transformer. VS, voltage across the secondary of the transformer. And we have this phi here. This phi here is magnetic flux present around the core of the transformer. Okay. Now, how does a transformer work? Transformer in a circuit. Now we have to connect the transformer in the circuit. So this is how we connect the transformer in the circuit. So this one here, this is now the actual symbol of a transformer. So in electrical diagrams, electronics, you will find a transformer is represented like this. So the following figure shows how a transformer is represented in a circuit. The primary winding, the secondary winding, and the core of the transformer are also represented in the following figure. So this is now the figure now. So this is let's start with the primary winding. So this is the primary winding of the transformer. The secondary winding, this is the secondary winding of the transformer. And the core, so this is the core of the transformer. If I remove this is the core of the transformer, this one here. These windings are wound on. So now how does a transformer work? From there you can see the primary is connected to the input voltage is connected to the primary, the output voltage is collected from the secondary. Okay, hence when a transformer is connected in a circuit, the input supply is given to the primary coil so that it produces varying magnetic flux with this power supply, and that flux is induced into the secondary coil of the transformer, which produces the varying EMF of the varying flux. As the flux should be varying for the transformer of EMF from primary to secondary, a transformer always work on alternating current. Why does a transformer only work on alternating current? This is because this is suitable current for the transformer because this type of current changes directions. Remember that we are designing a power supply whereby we say that we are going to take power supply will convert AC to DC. So this is why we are using a transformer. So the transformer will only be connected on the AC side. On the AC side. So you're going to see why we need a transformer in that project. Depending upon the number of turns in the secondary winding, a transformer can be classified either as a step up or step down transformer. So this transformer can be used to step up the voltage or to step down the voltage. What does it mean? In simple English, that it can increase the voltage and reduce the voltage. Let's say like that in simple term in English. Increase reduce. So a transformer is a machine that can either increase or reduce depending upon the application, okay, where they want to use. So let's start with the number one, step up transformer. When the secondary winding has more turns or has more number of turns than the primary winding, then the transformer is said to be step up transformer. Here the induced EMF is greater than the input EMF. The figure below shows the symbol of a step up transformer. So when you in a scenario whereby the secondary windings is more, you see the number of turns, these are the number of turns. So if you count, this is 1 2 3 4 5, but this one have 1 2 3. So automatically this transformer is a step up transformer. Why? Because the secondary turns is greater than the primary side. So the induced EMF is greater than the input. So the more the multiple turns, the more the induced EMF. Okay, that's what they're trying to tell us in simple terms. So step down transformer. Step down transformer, when the secondary windings has lesser number of turns than the primary winding, then the transformer is said to be a step down transformer. Hence, the induced EMF is lesser than the input signal. The figure below shows the symbol of a. If we can come back here, if we can come back here, if we can come back here, which type of transformer is this? Answer me in the comment section. This transformer here. So I'm not going to, just from the what I've explained there, what kind of transformer is this figure? This figure here. Answer me in the comment section as we proceed. In our power supply circuit, now let's now apply our transformer in the power supply unit. We use the step down transformer as we need to lessen the AC power to DC. The output of this transformer, of this step down transformer, will be less in power, and this will be given as the input to the next section called a rectifier, which we are going to discuss next. Whenever there is arises the need to convert an AC to DC power, a rectifier circuit comes for rescue. Okay, a PN junction diode acts as a rectifier, so we are not going to do that. So let me now mention something very important here, that in a power supply, I've said power supply, not other circuit. I've said power supply. We use step down transformer. Why? Because let me say if I want to achieve let me say if I want to achieve 5 volt at the output. Let me use the 5 volt at the output, whereby my input is 240 volt. Like for us here in Kenya, like between phase and neutral, 240 to 50, whatever, depending on what you measure. So I want to achieve 5 volt at the output of my power supply. So for me to be able to get the voltage from 240 close to 5 volt, I will need a step down transformer. So this step down transformer will step down this voltage, let's say from 240 to 15 to 24 to depending upon what you'll get, 48. You can see that is R12. Okay, so that when I get this, I will get my output. Remember that something to note now. How do you choose a transformer when designing your power supply? Number one, know your output voltage. First of all, you know your output voltage. What's going to be your output voltage? So if it's 5, what transformer can give you voltage from the 240 close to 5? If the transformer you will get is 12, okay, you will work with it. The 12, then you'll get 242 to 12 volt. So when you get 12 volt, now you can design, you can add up other parts until you get 5 voltage. So you have to know first of all the output you want to achieve. The current, this output is output voltage. Yeah? You also have to know the output current. Okay, the output current of your power supply. How much current? What is the current you want to achieve at the output? Okay. Then you choose your transformer. When you choosing your transformer, you'll have to consider voltage, current, and also your power. Power in watts. You will have to consider it. Okay. Yes. So that is the function of a power supply in the a transformer in the power supply to allow us get closer to the voltage we want to achieve. So this is the famous formula of a transformer. In a power supply, normally we don't design transformers. We don't design transformer. We choose. In a power supply, you choose the transformer. So this, I wanted to show you this. These are this is just a famous formula for the transformer. So in power supply, we don't normally calculate. We only choose. Okay. So if you find a scenario whereby you have to calculate, then you'll have to apply those formulas that I've shown you. So you'll have to choose the right transformer for your project. Like something like an inverter. An inverter will take this low voltage and increase it to very high voltage at the output. So a transformer gives us a privilege of taking the high voltage AC to lower voltage AC. Okay, so the input you will get, you will connect AC, the output you will get AC. Or the difference is that this one can be 250, this one here can be 12, but this 12 is AC, not, there is no other current here. So an input of a transformer is AC, the output of a transformer is also an AC. So guys, we can end there for today. Let's meet in the next video, whereby we will discuss, our next topic will be now to how to convert the AC to DC. Okay, so our next topic will be to convert the AC to DC. Thank you.